We will start our problem with a square. Then inside this square we will pull two lines, and those two lines will be equal in length and perpendicular to each other, as you can see on the sketch. Now, if the left line divides the left side of our square into two segments, from which the bottom one has the length of 2, and the upper area of this divided square equals 39, the question is, can we somehow calculate the side of the square, which we will label as x? So if you guys want to try this problem out for yourself, you can pause the video right now and then come back and check the solution. Alright, so let's solve this one together. So first I'm going to label all the vertices of our square as A, B, C, and D, and I will label the intersection point in the middle as P, and the intersection point with the left side of the square as Q. Now let's notice that since ABCD is a square, with the side length of x, this means that the length of the line AB must be x as well. Now let's pull a line from the point Q to the point B, and in this way we will form this really nice right-angled triangle ABQ. And we can use the Pythagorean theorem on this triangle to calculate the hypotenuse BQ. So BQ squared will be equal to the sum of the legs AB squared and AQ squared, and we can substitute the values for those two legs from our sketch. We can work through this and simplify, and we will get that BQ equals the square root of the quantity of x squared plus 4, and let's also put this value into our sketch. Now let's simplify this a little bit and let's take a look at the triangle BQP. This triangle is actually an isosceles right triangle, so it must represent the half of the square. And we can use this fact in our favor. But first let's do a quick reminder about the square. So if we have a square with the side length of a, we can calculate its area as a squared. Now let's pull a diagonal with the length of d. The diagonal of the square equals a square root of 2, and we can rewrite this equation in terms of a. Now, if we combine those two equations, we will get that the area actually equals to d over square root of 2 squared. Or, if we simplify, we will get that the area of the square equals d squared over 2. Now, if you take a look at our sketch, we can actually calculate the area of the square as bq squared over 2, since bq represents the diagonal of our square. But, remember, we're just looking at the triangle BQP, which represents the half of the square, so the area of this triangle will be equal to 1/2 of BQ squared over 2, and let's also label this area as A1. Now we can work through this and substitute the value of BQ from the sketch. We can cancel out the square root and square and get that this area equals x squared plus 4 over 4. Now let's have a look at our image once again and let's try to find the area of the triangle QAB. I will label this area as A2. As you can see, this triangle is a right-angled triangle, so the area must be equal to the half of the product of its legs, so 2 times x over 2. Of course, we can simplify this and get that the area A2 has the value of x. Alright, so now we can write down the equation for the area of our square, and we can say that the area of the square equals to the sum of all individual areas inside it, the area with the value of 39, A1, and A2. Of course, we will substitute our values, and we will substitute the value of the area of our square as x squared. Now we can simplify this equation by multiplying everything with 4 to get rid of the fraction, and finally we will put all terms on the left side of the equation in order to get this really nice quadratic equation of 3x squared minus 4x minus 160 that equals 0. Of course, you can solve this equation in multiple ways, but I will choose my favorite one, the quadratic formula. So if we have a quadratic equation in a shape of ax squared plus bx plus c that equals 0, we can use the following quadratic formula. Of course, in our case, a equals 3, b equals minus 4, and c equals minus 160. And we can substitute those values into our formula and get the following. Now we can just work through this and get this really nice square root of 1936. And this really nicely simplifies to 44. Alright, so now let's clear the image once again, and from this we have two possible solutions for x. The first one is that x equals 4 plus 44 over 6, so this is 48 over 6, and x equals 8. And the other one is that x equals 4 minus 44 over 6, so that is minus 40 over 6 or minus 20 over 3. But remember, we are looking for the side of the square, and side of the square cannot have a negative value, so the second solution is out of the question. And this means that the only possible solution for x is 8, and this is also our solution. The fun fact is that you can also easily calculate the area of the whole square as x squared, or the area will be equal 64. And you can easily calculate the area of the quadrilateral AQPB as the difference between 64 and 39, and that is 25. So I really hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. Of course, if you found another way to solve this problem, please write it down in the comment section as you always do. And until next time, see you all and take care.